I'll do the worst one with you. Just like the others, if you need more space, feel free to get another sheet of paper for some of your work. So this is all the same stuff, but if you look at your directions, I also ask that you find horizontal and vertical asymptotes, because it's not a polynomial, it's a rational function, so we have both of those. How do we find vertical asymptotes? So what makes x cubed equal 0? 0. Okay. How do we find horizontal asymptotes?
We set the equation equal to our limit going towards infinity.
We have to do the limit as we approach both positive and negative infinity. As long as it's just a polynomial over a polynomial, so no piecewise, no radicals, nothing weird like that, they will be the same. Would you guys be okay if I just said, well, I know both these are polynomials, so I'm going to do the limit as I approach positive and negative infinity and do them at the same time? So as long as you don't have radicals or piecewise, this should work. Just a polynomial over a polynomial, which are all of these problems. Okay. Now, if I just plug in infinity right now, it is really hard to know what this is going to do. So what did we do to simplify that? We would multiply top and bottom by 1 over the highest power of x. So we get negative 9 over x minus 9 over x cubed over 1. Well, a number over infinity goes to 0, so we have 0 minus 0 over 1, which is 0. So our horizontal asymptote, y equals 0. That's our asymptote bit. Next, we need critical points. So we have to do our derivative. I think it's easier to go ahead and just do quotient rule versus trying to break this up. So low d high derivative of the top is negative 18x minus high d low over low squared. So we get negative 18x to the 4th. I'm going to distribute a negative and my 3x squared. So plus 27x to the 4th, 27x squared over x to the 6th. I can combine like terms and also reduce x squared. Take an x squared out of everything. So that would give me a 9x squared plus 27 over x to the 4th. Oh, hold on. Did I write my problem wrong? It's a very quick fix. There was the negative was out here, wasn't it?
Yes.
So that would really make this like a negative 9x squared and a positive 9. So the only thing that will change is right here. That'd be positive. I just copied my problem down, but wrong. So this would make it a minus 27x squared, so a minus 27. Sorry about that. So critical points, we need to know where this is 0 or undefined. So when it's 0, that's when the top equals 0. X squared is 3, so we get plus and minus the square root of 3. Undefined is when the bottom is 0, and we just get 0. So my critical points plus and minus radical 3 and 0. So then we do our sign line. So smaller than the square root of 3, so maybe -2. In between, maybe -1, between 1 and 2. And I'm plugging these into my derivative. So if I put in a -2, 36 minus 27 is positive, -2 to the fourth is positive, so that's positive. If I put in -1, 9 minus 27 is negative, over a positive is negative. If I put in a 1, 9 minus 27 is negative, over 1 is negative. Put in 2, 36 minus 27 is positive, over 16 positive, so we get a positive. So that tells me my graph is increasing from negative infinity to negative radical 3 and radical 3 to infinity. Decreasing. Can I just say from negative radical 3 to positive radical 3? You're shaking your head, Bryson. Why did you say no?
Because it's asymptote.
Okay. You can, unless this point is your vertical asymptote. So if it were over here, where both sides are positive, the radical 3 wasn't my asymptote, then we would just say the whole thing. Because we have a vertical asymptote in the middle, we do have to break it up. So we'll just say from negative radical 3 to 0, and 0 to positive radical 3. All right, max and min. So here we went increasing to decreasing, so that's a local max. We need our y value, so you have to plug it back in here. Negative 27, 9, so negative 18, or negative 3 radical 3, 6. So 2 radical 3? You guys just are way too trusting. Nobody even tried to check my math, did you?
I don't use calculators so much.
Yeah, you're a lot faster than I am.
Do you guys know how we get them anyway?
Yes.
Okay. The min. So here we went decreasing to increasing. So at positive radical 3, the only difference then we would have a negative over positive. So we would get negative 2 radical 3. I think the problems I gave you have much nicer points. Like you might have an inflection point with a radical. I don't think any of the critical points do. So I think the other problems are a little bit prettier than that. Once we have all this, what do we have to do? Inflection points. So second derivative. So I'm doing from my first. So low, d high, minus high, d low, over low, square. So I'm going to distribute my negative and my 4, so minus 36. Okay, I can reduce x cubed and combine like terms. So we get negative 18x squared plus 108 over x to the 5th. So inflection points, when that is 0 or undefined. So to figure out when it's 0, you set the top equal to 0. So plus and minus the square root of 6. Or when it's undefined, which is when the bottom is 0, which is still 0. So those are my inflection points. So to check our concavity. So smaller between, when we are plugging these into the second derivative. So you may need a calculator now. So if I put in -3, I get -54 on top, I get a negative on the bottom, so 2 negatives make a positive. If I put in a -1, I get a positive on top, negative on the bottom, so negative. 1 gives me a positive over a positive, so positive. 3, a negative over a positive is negative. So our graph is concave up from negative infinity to negative radical 6, and from 0 to positive radical 6. It is concave down from negative radical 6 to 0, and radical 6 to infinity. For the purposes of graphing, we need ordered pairs for these. If we plug those back in, I'm just going to go ahead and get the decimal here. Right, what'd you guys get when you plugged in a negative radical 6? .28? We put in a positive radical 6, we get a negative 4 point, I guess it's really 4.29. We could be more precise with this, but we're just trying to figure out exactly where to plot it on our graph. All right. Oh, hold on. I plugged that in wrong. That's stinking negative again. It's because I changed the problem on my original and I tried to write in the problem beside it and it changed. Should be 3.06, a negative 3.06. Need to rewrite the problem on my homework page. I didn't want to redo my whole answer key once I got to my final question and realized it was ugly, so I just scribbled it out on my key and changed the problem. All right, so now let's graph it. We have a vertical asymptote at 0 and a horizontal asymptote at 0. Okay, my max was at negative radical 3, so that's like a negative 1.7, to radical 3, which is about a 3.5. Okay, and then I'm in. Was that to positive radical 3, negative 2 radical 3. Inflection points will mark with an X. Square root of 6 is a little past 2. It's like 2.44. So we have at negative square root of 6, so negative 2.4. My y was 3.06. And then positive 2.44 is at negative 3.06. Okay, we know our graph starts off increasing and it's curved upward until we get to the x. So increasing but curved upward. Get to my x, it's going to be a slight change to curve downward. I hit my maximum, so now it's decreasing. But remember, we have an asymptote here. What happens at a vertical asymptote?
It just gets closer and closer.
Right, so it's decreasing, just getting closer and closer to this. So it looks like that. Okay, then our graph is decreasing again after 0, but it's curved upward. So decreasing, curved upward, we hit our min. Then we're going to be increasing. We're still curved upward until we get to our x. Now it's a slight change to curve down. So our graph looks something like that. All right. Definitely the ugliest question on here, by far. Did I lose you anywhere? So why don't you guys try some of these?